Hey there guys, in this video we're going to be taking our first look at stationary points. Now a stationary point is just a point on a curve where the gradient is equal to 0. Now we can use differentiation to find the coordinates of these points, which is what we're going to be doing in this video. So there are three types. There are minimums, maximums, and points of inflection. What we're going to do in this video is introduce each of the three types, and then we're going to be using first order differentiation to find the coordinates of these points. So the most important thing to take in here before we get going is at a stationary point dy by dx, our derivative is equal to 0. The gradient of the curve is equal to 0. So again, here we're going to be using first order differentiation to find the coordinates of these points. In the next video, which I will link down below, we're going to be using second order differentiation to classify the stationary point as either a minimum or a maximum. So first up, what do the three different stationary points look like? So first up, a minimum. We've seen these loads before. The bottom point of a quadratic. We do get minimums and maximums though, locally on cubic and higher power graphs too, so it's not just quadratics. So a minimum point looks like this. So to the left of a minimum, our gradient is negative, so it's less than 0. So the curve comes down to this minimum point where it doesn't go any lower, locally at least, and then here the gradient is equal to 0, and then on the right the gradient picks up again, so the gradient is greater than 0, it's positive, so the curve is increasing again. So a maximum is the complete opposite. So to the left of a maximum, the gradient is positive, so it's greater than 0 until it gets to this point where the gradient is 0, so that will give us our maximum point, and then as soon as we are to the right, the gradient starts to be less than 0, so negative, so the curve starts going down again. So that's what a maximum looks like. Now a point of inflection is one where the gradient to the left of the stationary point is the same sort of gradient as the gradient to the right of the stationary point. So here with my example here, on the left and right, the gradient of the curve is positive. So what's happened? Coming up on the left, the gradient is positive, but it's sort of decreasing. It's getting more and more gentle until it gets to this point where it's equal to 0, but then instead of turning around and becoming negative, it's changed its mind and it's just gone, actually I'm going to carry on being positive. So we could also have a point of inflection with a negative gradient on the left and a negative gradient on the right. So that's our three different types. So now we're going to have a look at finding the coordinates of these points. Okay, now nicely there is a set routine to doing this. So remember, a stationary point is a point on a curve where the gradient is equal to 0. So in terms of a curve, the gradient is dy by dx, our derivative. So step 1 is to find dy over dx. So that is our gradient function of the curve. Our second step then, we want to find the x-coordinates where the gradient is equal to 0. So we then solve dy by dx is equal to 0. Now that will find us any x-coordinates where the gradient of the curve is equal to 0. Once we've got the x-coordinates, we then sub those in to find the corresponding y-coordinates. So, sub in x values. Now you sub those in to the actual function, not dy by dx. Remember, if you sub them into dy by dx, you will just get 0, because we are finding the x-coordinates that make the gradient 0. So sub the x values into the function to get the y values. Okay, on with that. Let's rock. Okay, first example then, we're going to start off with a nice quadratic. So, we could find the stationary point here by completing the square, but we're in a differentiation playlist, so that would be silly. What you can do is check that you complete the square with this and get the same answer as we get using differentiation. So, first thing we want to do is differentiate to find the gradient function. So, dy by dx is going to be 2x plus 8. Okay, so that's our gradient function. Now we want to find when that is equal to 0. So for step 2, we set dy by dx equal to 0. So 2x plus 8 is equal to 0. And now we want to solve that. So take away 8. 2x is equal to minus 8. Divide by 2. X is equal to minus 4. So we now have our x-coordinate of the stationary point. So for step 3, we sub in x equals minus 4 into the function. So the function is x squared plus 8x plus 12. So we're going to get minus 4 squared plus 8 lots of minus 4 plus 12. Now minus 4 squared is 16. So we got 16 minus 32 plus 12. So that gives us our value for y. So y is equal to minus 4, 2. So our stationary point has coordinates minus 4, minus 4. As I said, if you want to practice your completing the square, make sure you can get the same answer using that method. Okay, example 2, we're going to go for y equals x cubed minus 3x plus 10. So here we got a cubic, so we might expect for there to be maybe more than one stationary point. Not definitely, but it could happen. So, step 1, differentiate. So dy by dx, well, that's going to be 3x squared minus 3. So that is our gradient function. Next, we're finding stationary points, so that, or those, are where the gradient is equal to 0. So set dy by dx equal to 0. So that gives us 3x squared minus 3 is equal to 0. And now we want to solve that for x. So add 3x squared is equal to 3. Divide by 3. X squared is equal to 1. Now be very careful here. When we square root, we get x is equal to plus or minus 1. So we've got two stationary points here. One where x is minus 1 and one where x is positive 1. So now we want to find the corresponding y coordinates. So we substitute each x value separately into the original function. So our function is x cubed minus 3x plus 10. So if we evaluate y when x is minus 1, we get minus 1 cubed minus 3 lots of minus 1 plus 10. Now minus 1 cubed is minus 1. Minus 3 times minus 1 is positive 3. So minus 1 plus 3 plus 10 is going to give us 12. So one of our stationary points has coordinates minus 1, 12, and then to find the other, we're going to substitute in x equals positive 1. So y evaluated when x is 1 is 1 cubed minus 3 lots of 1 plus 10. So 1 cubed is 1, minus 3 times 1 is minus 3. So we've got 1 minus 3 plus 10. So that is going to give us 8. So the coordinates of our second stationary point are 1, 8. Good times. Okay guys, so that's how we find the coordinates of stationary points, differentiate, set the derivative equal to 0, solve for x, substitute in any x values to the original function to get the y values. In the next video, we're going to be doing more of this, and we're also going to be classifying the stationary points that we find using second order derivatives. Hope to see you there. Take care guys.